All right, now I want to show you some pseudocode for the first part, which is adding the particles to the tree, and I'll show you kind of a clever way to do it. You can certainly just um, divide the subspace, and as you divide the create children for each region, you can ask how many particles are in this region. And if there's more than one, you can divide it again and then ask the question again. But you end up having to scan all the particles at every step. And remember, we have to build this octree at every time step in the simulation of the movement of the bodies. So you want to think a little about being efficient. If you did it that way, that's perfectly fine, though. I'll give you another idea in case you want to do it more efficiently or if you're just a little stuck. So let me share the screen and go over a little bit of pseudocode with you. Okay, so hopefully you can see the right thing. This function will be called quadtree build, and it's a classic way to do it based off of people who do these things. Um, Again, not the only way by any stretch. I did it a couple different ways. So the way we're going to do this is, again, the pseudocode doesn't get into details on what data structures look like. So I'll show you some choices that I made. But we're going to start with just an empty quad tree, and then we're going to loop over all the particles. And the way this is going to work is we're going to put the particles one by one in the quad tree, and we're going to refine the quad tree as we start adding more particles and see that we need to refine it. Okay, so when we add particles, we push the particles that were already in that node down one level deeper and refine. And it's going to turn out to be more efficient than if we just keep scanning all the particles to see where they fall in this boxology. Okay, so it's recursive and it's a little tricky. I'll post this and make sure that you look at it carefully. But I'll try to walk you through some of the key features quickly. Okay, so you're going to do this for each particle. You're going to call quad tree insert on the root, where the root obviously represents the root of the quad tree. And when you call insert the first time on root, there are three possibilities in this recursive algorithm. So either it's an internal node, so the node already has 4 children, and that's not going to be the case yet because root's empty. The node is a leaf that contains a particle, or the node is a leaf that is empty. Well, that's going to be what happens the first time through, right? So the first time through, we're going to pass it the root, and it's just going to store the first particle in the root. So when I say store the first particle in the root, you have to imagine that the node of the tree has a field, which is a particle, okay? Or something that holds up a void pointer or something that you reuse for nodes that don't have particles, up to you. All right. That's the first time through. So the root node has a particle, and now you do the second particle. Okay, so you call insert on the second particle. Now in this case, it's going to be a leaf, but it contains one particle. So it's going to evaluate to this condition. So you're going to add the 4 children. What it's basically saying is now that you've got a second particle in the same region, that's no good. So you're going to have to refine that region, right? Well, it's obvious with root, but this is true now recursively for every subregion. So that's what's nice about it. So you add the 4 children, and the particle 1, or the first particle, I should say, that was in the root node, now you have to say which of these subchildren does that belong to? And you have to move the particle out of the root node into the subchild. Okay. And I'm going to say it's child 0. So child 0's particle field now has the particle, and the root particle field is empty. Okay. So then you're going to call quad tree insert now on that child. You're going to do it recursively with j equals 2, the second particle. Okay. So when you do that, you're going to, that obviously has a particle in it. So there, let me be clear, there are 2 different things here. There's moving the first particle that you put in into the child containing it. Then you have to find the child that contains the second particle. Sorry if I misspoke. So the second particle, which is now j, j equals 2, might be the same one that the first one was in, or it might not. Let's say it's a different one. Okay, then you call quad tree insert on that separate one, and then you're finished with that particle. Because that node will be empty, and so you'll just store the particle in that node, and then you'll move on to the third particle. If it moves it into the same child as the first particle was stored in, then you're going to have to split again, because you're always going to go until you have 1 or 0 particles per node. Okay, so that's the essence of it. It's just a nicer way of adding the particles to the tree than having to look at all the particles every single time that you divide up the domain and ask which of them are in the domain and which aren't. It's many fewer operations. Okay, so you could implement this literally in C, and you will need to add some detail that isn't here, which is going to be a lot of what makes it interesting and fun to do, and it's going to be a lot up to your style. But what I can show you is the way that I did it. So I mimicked this function, and I'll do it to sort of show you the spirit and give you some ideas. I certainly don't expect you to do exactly what I did, and I won't show you enough such that if you did, it would really help that much anyhow. So I'll give you a flavor of it. So let me switch to my terminal window and show you my implementation of that.